understand the problem. Okay, another problem. A parallel plate capacitor with a plate area of 2 meters squared and a separation of 1 millimeter is charged to 100 volts. What is the electric field between the plates? What is the charge on the capacitor plates? Find the energy stored in the capacitor. Okay, let's see what are the given things. You know the area of the plates is 2 meters squared. The plate separation is 10 to the negative 3 meter. And the potential difference between the capacitor plates is 100 volts. What is the electric field between the plates? Can you tell me what equation we will use for electric field? We have two parallel plates, and you should know by now you have two parallel plates separated by a distance d. What is the electric field between these two plates? Well, E equal to dV over dr, isn't it? Potential difference divided by the plate separation will give you the electric field. Don't forget that. Those are basic relations, basic equations. So, the electric field between the plates E equal to V over D, potential difference divided by the plate separation. That is 100 volts divided by 10 to the negative 3 meter, and that will be 10 to the 5 volt per meter is the electric field between the capacitor plates. Next one. What is the charge on the capacitor? Well, you know the voltage, and what else do you know? What else do you need to know to find the charge on the capacitor? Well, it will be nice to know the capacitance of the capacitor. Now, is there enough information here for us to find the capacitance of a parallel plate capacitor? What is the equation for the capacitance of a parallel plate capacitor? Capacitance is, all right, kappa epsilon naught A over D. Is that right? Yes, I think so. First, we obtain the capacitance C of the capacitor. C equal to kappa epsilon naught A over D. Well, kappa is 1 because if the dielectric is not mentioned, we will assume that it is air. Epsilon naught we know, A is given, D is given. Use all those values. We get C equal to 1.77 times 10 to the negative 8 farad, which is 17.7 nanofarad. Alright, now you know the capacitance. Once you know the capacitance, we can find the amount of charge on the capacitor. Q equal to CV. Is that right? I hope when I give you these relations, it resonates with you. And now, the only way it can resonate with you is that after listening to my lecture, you go back and do your homework. And also, be active when you listen to the lecture. Alright? Be an active learner. Don't just sit back and listen. That will only make you sleep. Be an active participant. Have a paper and pencil. Always keep writing and keep these calculations current with your calculator. Alright, Q equal to CV. We have now obtained the value of C. We know the potential difference. Therefore, Q equal to C times V. That will be 1.77 times 10 to the negative 6 coulombs, which is 1.77 microcoulomb. Find the energy stored in the capacitor. Well, energy stored is 1/2 CV squared or Q squared over 2C. We can use this. Energy of a charged capacitor is 1/2 CV squared. 1/2 C is 1.77 times 10 to the negative 8. Is it 10 to the negative 8 or 10 to the negative 6? Well, it should be 10 to the negative 6. Yes, you've got to make that correction. So you know how important it is to keep up with this and to correct these small printing errors. So that must be 10 to the negative 6. And see if this is correct by making that correction. Alright, 8.85 times 10 to the negative 5 joules is the energy. If it is not correct, you got to do the correction on your own. Alright, let's go and look at another problem. A parallel plate air gap capacitor has a capacitance of 0.14 microfarad. The plates are 0.5 millimeters apart. A. What is the area of each plate? B. What is the potential difference if the capacitor is charged to 3.2 microcoulomb? What is the stored energy? How much charge can the capacitor carry before dielectric breakdown of the air between the plates occurs? Now remember, a capacitor is useless once dielectric breakdown occurs. So you can't allow that to happen. Okay, let's see what are the given things. You are given the capacitance, that is 0.14 microfarad. The plate separation is 0.5 millimeter, which is 5 times 10 to the negative 4 meter. The charge on the capacitor plates, we need in B part, we want to find the potential difference when the amount of charge is 3.2 microcoulomb. Okay, and it's the air gap capacitor, kappa equal to 1. In part A, what do we need? What is the area of each plate? Well, you know the capacitance, you know the plate separation, you know kappa, you know epsilon naught. We can find the area because the area of the capacitance of a parallel plate capacitor is kappa epsilon naught A over D. The only unknown there is your area. So solve for area from there. Area equal to CD divided by kappa epsilon naught. And you know the capacitance. Is that right? That will be 0.14 microfarad is 1.4 times 10 to the negative 7 farad. D is the plate separation, is this. Kappa is 1 and epsilon naught is the usual value. And that gives you the area is 7.91 meters squared. You notice that the area of the parallel plate capacitors have to be fairly large to construct capacitors of significant value. B, what do we need to find? We need to find the potential difference if the capacitor is charged to discharge. Well, that's very simple because you have the basic definition of capacitance, C equal to Q over V. You have the value of C, the capacitance, well, and we just obtain, and we have the value of amount of charge, do we? Yes, we know the amount of charge, so we know C, we know Q, therefore we can find V, the potential difference. V equal to Q over C, and use the Q is 3.2 microcoulomb, 3.2 times 10 to the negative 6 coulomb, and C, the capacitance is 1.4 times 10 to the negative 7 farad, and that will be 22.9 volt. What is the stored energy in the capacitor? You know the value of C you know the value of V, the stored energy is 1/2 CV squared. And use the values of C and V, we get the stored energy is 3.67 times 10 to the negative 5 joules is the stored energy. And finally, what is it that we want to find? How much charge can the capacitor carry before dielectric breakdown between the plates occurs? Now, when will dielectric breakdown occur? Dielectric breakdown will occur if the electric field between the capacitor plates is greater than 3 times 10 to the 6 joules per coulomb. The electric field between the capacitor plates, the maximum electric field to prevent this phenomenon is 3 times 10 to the 6. Let's find the electric field first. You know that the electric field between the capacitor plates is sigma over epsilon naught. Now you cannot tell me that you don't know that. That is something that we have been using several times. You have two parallel plates, one charged positively, other charged negatively. The electric field at a point in between the two plates, anywhere, will be a constant given by sigma over epsilon naught. And we can therefore find the sigma. Sigma equal to E times epsilon naught. Well, what is the value of E for dielectric breakdown? E should be 3 times 10 to the 6 volts per meter. So we can now find sigma equal to E times, E is this, and of course epsilon naught is our friend now, so you know its value. There you are, sigma equal to E times epsilon naught, that is 2.655 times 10 to the negative 5 coulombs per meter squared is the charge density, the surface charge density. Well, if you know the surface charge density, how would you find the total charge on the capacitor plates? I think that's simple, because surface charge density multiplied by the area of the plates will give you the total charge on the capacitor plates. Q equal to A times sigma, that will be, area is 7.91 meters squared. Sigma we just calculated, therefore Q, the capacitor plate, the maximum amount of charge the capacitor plates can hold before dielectric breakdown occurs is 2.1 times 10 to the negative 4 coulombs. Alright? Now you can see all these are basic problems we are doing. We are not doing any complex problems. But I want you to be familiar with this. Okay? Let's do another one. A parallel plate capacitor is made by placing polythene of kappa equal to 2.3 between two sheets of aluminum foil. Just the same capacitor I just showed you. The area of each sheet is 400 centimeters squared and the thickness of the polyethylene is 0.3 millimeter. Find the capacitance. Well, that's a very straightforward problem, isn't it? Yes? Capacitance is kappa epsilon naught A over D. Don't we have all those values here? Yes? Kappa is 2.3. D, the plate separation, is 3 times 10 to the negative 4 meter. Always remember to use the correct unit. The plate area is 400 centimeters squared, which is 0.04 meters squared. And I think we have everything that we need. Capacitance is kappa epsilon naught A over D. And use all the known values. And just don't leave it for me to calculate. I want you to do that on your own. And that will be 2.71 times